Hey everyone, thanks for joining us for this webinar co-hosted by ProfitApp and Kadiska. So I'm Scott Sumner from Kadiska and I'm here with John Maudlin for ProfitApp.
Hey.
So today we're going to look at a little bit of the new challenges that happen when you have a lot of distributed edge locations, people in remote, maybe work from home, people at headquarters all trying to have a voice over IP call that might not be going 100% the way you expect it to. So take you through the scenario. We're going to show you a live demo of how to use the tools we have to really resolve those issues quickly and figure out where they're coming from. So first thing I'll take you through here, just a quick background of what's happened to the business landscape in terms of the way IT infrastructure is now being deployed. It's changed quite significantly over the past couple of years, been accelerated by the pandemic. We're seeing highly distributed networks right now, a lot of different branches. You can think retail stores, manufacturing sites, satellite offices, and also work from home, making that even more distributed and difficult to monitor. And this is leading to more intermittent issues. The network is bigger, it's more complex, and it's also can affect people regionally very quickly that we didn't see as much when people were all connected in to head office kind of locations. The other big change that you're all living, I'm sure, including things like a live stream like this, cloud, SaaS, SD WAN migration. So a lot of dynamics happening at the same time that make it difficult sometimes to see where problems are coming from, because with encrypted traffic to the SaaS and the cloud, there's less ways to instrument the traffic at those locations. So you can really have to have a plan for capturing the traffic on the edge locations where it's easy to capture and analyze, and also tools that can allow you to see across the network. So this is a bigger problem than most of us will imagine. I think we're seeing studies coming out saying about 39% of issues that people call in to help desk in IT are completely invisible to the systems they have. And that makes it extremely challenging, mostly to isolate where the fault is coming from. And that's what we hope to show you we're going to do today. And then when you have the idea of where the fault actually is, and it's reasonably easy to troubleshoot, then you can collapse that mean time to repair down to just a few minutes. First, I'd like to introduce who ProfitApp and Kadiska is for just a few minutes. We do have a partnership together because we naturally complement each other in creating a continuous visibility across edge all the way to the cloud. So I'll let John explain a little bit about ProfitApp and where you guys come from.
Yeah, hi, I'm John Maudlin, the Senior Systems Engineer for ProfitApp in North America. The IOTA product that we're going to show you won Best of Show at Interop, and it's a small form factor capture sensor visibility appliance that you put at your location, either inline or in span mode, so that you can drill into your traffic and it captures your packets there locally.
Yeah, it's a pretty cool device. And I've seen you use it live, John, and I think you're going to take us through a tour of how it really makes things simple. Get data from those edge locations into where the analysts are, right?
Yeah, let me show you what I've got here. Can you see that okay? Can you see my screen okay?
Yeah, there you go.
Okay. This is what the IOTA actor, it's about 6 inches long. It's got a couple of tap ports on the front. You can manually start and stop your capture, or you can do it remotely. It has a nice remote access feature. And then you just can plug your management port into your network, get an IP address and web right to it, and use the heavy client that's built in to access dashboards and stuff where you can get access to your packets that you're capturing on your network. We have one running here. And in the interesting traffic we're looking at, I'm going to go back 30 days here and just look at traffic. And here I have traffic that VoIP traffic. It's let's say somebody submitted a ticket and they had a problem on this traffic. And so we've captured it and we're looking at it here on the IOTA. And here's the interesting IP addresses.
Hang on, before you hop into that, John, I'm just going to show people quickly the scenario you're going to be analyzing in just a second, if that's all right.
Yeah, sure.
Yeah, so that's exactly what the IOTA can do, right? It can pull that data out from any location and then remotely let you analyze it. So let me just show you quickly what we're going to look at. The context is something like this, where you have different locations across the network going from the branch offices, work from home, headquarters to the cloud. And the complexity here is the cloud visibility makes it difficult to know where the traffic has gone. And it's hard to capture data at these remote locations. But I guess, John, where you guys are capturing really the key locations, any edge and headquarter location where you need to analyze the behavior of the traffic, right?
Yeah, that's correct. We're assuming that this is at an edge client location right now.
Okay, and that's the idea here, is that there's a complement between Kadiska and ProfitTop, that we can do the tracing through the network to the cloud, and we can also monitor user experience and trace the network performance from the same locations that ProfitTop has their devices. So that gives us the ability to correlate things together. I'm just going to show you what we'll look at. Imagine you have a scenario where there's like John said, some calls coming into the help desk where there's call quality problems in that particular environment. That he's going to take you through, like how you can detect exactly what's going on and where it's coming from. And then we'll take a look at how the network can be monitored to figure out where along those paths the problem happened. Okay, John, all yours.
Okay. So here on the IOTA, can you still see that okay?
Yep.
Here on the IOTA, you can see the interesting IP addresses that are involved in the traffic here. And we've narrowed down the time frame to just about, looks like about 20 minutes here of time for these calls. So I know this is a VoIP call, so I'm going to go to our VoIP dashboard here. We've already selected the time frame we want to look at. And here I can see the IOTA has analyzed that traffic, and I'm looking at my interesting call data, how many calls I have, and I can see the interesting SIP messages that are happening between the devices. And I can see the interesting codecs that are involved in the traffic, this being G.711. So now I want to take a look and see, is there a problem with this traffic? So I'm going to go to the call detail dashboard, and I can see my flow identifiers. I can see my my call flows, and I can see callee jitter and caller jitter. And down here, I have a graphical representation of that. And right away, I can see here that we have a call that has 200 milliseconds of jitter, and that's a lot of jitter for those of you who don't know. So I'm going to zoom in on that because I know that's going to be some kind of a problem. And right up here, I can see here's my 200 milliseconds jitter. So I want to take a look at this particular call ID, kind of see what was going on. So now I'm looking at that particular call here, and I can see that I have quite a bit of packet loss here that happened. 100% packet loss up here. So that is the problem. And if I go to the Explore dashboard, I can tell what are the interesting IPs involved in that phone call. So I can see this is going to be the call gateway and then the user involved in the traffic over here. So from there, we know there's a problem. We can see it happening at the user's location. We know it's involved in jitter and packet loss. And so it looks like the packet loss is upstream. And in that case, we don't have visibility to that upstream traffic. And that's where Kadiska is going to come in.
Oh, thanks, John. That was really fast that you're able to pull it down to that single conversation and the endpoints, right? So from there, you know what locations they're at. And so in a large conference call, you've already narrowed it down to that one thread.
Yeah,
so that's a pretty fast way to get to the next step, right? And that's the kind of thing that Kadiska isn't seeing every individual call to every individual person, but having this information means we can go and take a look real quick at what's actually happening in the network. So I'll just take you through quickly what would happen if this was a call that was happening through something like a cloud PBX. So in this case, I'm just showing you data to the locations in this enterprise we were talking about that are accessing via cloud for their voice over IP hosting and streaming. And you can see the different locations around here. So we know that the call that we were just looking at, that John was showing, was actually a three-way call that was happening between Finland, Toronto here, and San Jose, California. And you can see an indicator here. There's already a bit of packet loss on this line, and there must be some sort of jitter and latency also happening. So the idea here is to kind of take a look and see exactly what's happening at those different sites so we can correlate that with the user's experience. So in this case, we'll take those three locations that we know were involved in the call. And so those three sites, and take a look at how they actually got to those cloud servers and what it meant for the voice over IP experience. So taking a look quickly here, you see on the top, this is the packet loss. So it's you can see from the site in San Jose, there is quite a bit of it here, spiking well over 10%. So there was a moment there where it was up to 100%. The network connectivity isn't great. You can also see that the latency is consistently very high in San Jose, whereas the other sites like Helsinki, Toronto, there's times where it goes up and down depending on a change of path. So the path length is indicated on the right. So if we want to really look at this, you can see that each location, San Jose, for example, Toronto and Helsinki, are going to different destinations. So they're going to different hosts within the Avaya cloud. And that means they're all have their own unique way of getting there. And this graph here is showing you exactly how, in San Jose, they're getting from there across the United States and then into ultimately the cloud office of Avaya.com, which is hosted in the AWS infrastructure in New Jersey. So you see Toronto is not connecting to the same one, and neither is Helsinki. And what that means is these are only one leg of the call. If I just simplify this down a little bit, all these cloud office locations have to connect to each other to bridge that phone call together. So there is going to be even more latency connecting Helsinki to San Jose when they all get integrated together. But let's just take a look and see where those guys in San Jose were having the problem. So we'll just highlight delay. First of all, and you can see San Jose here has a couple of legs that are 70 milliseconds, which is an awfully long delay time. You're going to want to keep call latency down to 50 millisecond in one direction or 100 millisecond round trip for that to be successful. But if you look at that 70 milliseconds and you add it into what the guys in Helsinki are sometimes getting when they're going through a specific route like this one, then they're actually well over 100 milliseconds for the call. So the problem here in the Finland office is that they're actually tunneling from Helsinki normally into the UK and into servers over there. But in this particular case, they're actually transiting into Russia, which is kind of like not the way you want to get to a cloud server, right? So that's not necessarily the best way to go. And it transits back into France. So it's kind of a long latency route. And same with San Jose, that there's a problem here in the Telia network because it has a lot of delay just in that particular location. And the same thing can be done with packet loss that John was showing you. So over in Finland, there's a small degree of packet loss, but anything over 1.5% is going to impact your voice over IP call quality. You look in the US, basically every server that this location has tried to connect to during the call or calls to that during that office, or all have much more than the amount of latency and loss that you'd expect. So this allows you to quickly have a conversation with two people. In Helsinki, you'd be wanting to talk to this service provider here and seeing why this local provider is peering the traffic into Russia. That would be one place to go and have a conversation with your service provider. And the other one here is actually within the Amazon cloud. So this is hosted in Amazon, and there's a lot of internal packet loss happening within the AWS cloud. So you'd call Avaya up and ask them to see if they can resolve that issue. And then you can also look at working on with Telia why they're passing you around the country just to get across there to a cloud server. So between the two solutions together, the way John showed you, we identify the call, get right down to the detail of what's happening in the moment, packet loss, jitter, latency, and then we can go out there and find where is it in the network that's beyond the corporate LAN or WAN and try to figure out where the problem is.
I really like the way Kadiska does that on the cloud side, because that's always been a challenge. figuring out latency once it leaves your site and goes out into the internet. That's always been a gray area to do latency and performance checking. So that's really cool.
Yeah, it's two things that, when you put them together, they really give you the end-to-end picture. And that's why our customers appreciate that kind of partnership we have together, so that these two solutions can really give you that end-to-end view.
Yeah.
That's cool. I guess time's up. It's great to share with you guys. Just a quick demo. If you want to learn more, you can find out more information on our website, and you can learn a bit more about our partnership. So just reach out to us on LinkedIn, and John and I can respond to any questions you might have. And there on the web, you can see location to learn more about how our two solutions work together. So thanks everyone for joining us. Thanks, John. That was awesome, man.